and let's get started. So today what we're going to be working on is finding the greatest common factor. So yesterday we learned how to factor, and some of you did some practice with factoring. I'm glad that you didn't use up both of your attempts. If you were struggling with factoring and you needed some more help with it today, we're going to get that help today during class. So please pay attention as we work to find the greatest common factor. After this lesson today, Ms. Neville's also going to explain to you what your assignment is. Remember, we want to use our time wisely. So during math class, we only want to be working on math assignments. So that means any missing assignments you have until 1:44 today to just focus on math. Start training your brain that way, okay? Let's go ahead and share Ms. Neville's screen. And if you would please draw these two factor trees. You see that Ms. Neville has helped you out a little bit. I have written some of the factors in here. I've written some of those factors in for us already. And we're going to practice some with factoring. We want to remember when we're talking about factoring, a factor is a number that we multiply by another number or numbers to find a product or answer. Just as an example here, because we've got some kids in here who weren't in here yesterday, which is fabulous. We want to remember that with a multiplication problem, we're going to see factors and multiples, okay? Actually, I want to make this one a little bit tougher so that you can see. 2 and 10, these are considered factors. We should have written this in our notes yesterday. If you were not in class yesterday, you need to add this to your notes. So 2 and 10 are factors. Yes, we multiply those two numbers together to get 20, which is our multiple. Okay? So it's important for us to know the difference between factors and multiples, because as we start finishing up this week and going into next week, we're going to be discussing least common multiples. So we want to make sure that we're taking our time there. So you should have already drawn both of these factor trees. So let's please, I'm going to erase this here. Remember, I'm recording this lesson. So if Ms. Neville ever goes too fast for you, wait for the lesson to be uploaded to Schoology, and you'll be able to go back and get any notes that you may have missed. So can someone please turn on their mic and tell me, what would I call 40? How would I describe the number 40 in this factor tree?
You're a multiple.
It's a multiple, very good. This also has a lot of factors. In other words, there are a lot of numbers that can be multiplied by one another to reach 40, to equal 40. So not only is 40 a multiple, we would also say that 40 is a
composite number.
Composite number. Please add this to your notes if this is still new to you, if you're still learning this. 40 is a composite number because it has more than two multiples or two factors, and 40 is a multiple because many numbers are going to equal to it in this tree today. So let's complete the factor tree that Ms. Neville has started for us. So 8, I just gave you the answer. What number times 5 will equal 40? 8, very good. Notice how Ms. Neville's going to pull this 5. I'm going to drag this 5 down. Why?
Because it's a prime number.
Very good. 5 is a prime number, so it's going to reach all the way to the bottom of my factor tree where the prime numbers live. So 8 times 5 is 40. Is 8 prime or composite? It's composite. What number times 4 will equal 8?
2.
So I'm going to drag this 2 down to the bottom. Can someone put on their mic and tell me why?
Because nothing can equal 2.
Yeah, Jalen, how could I describe 2? Starts with a P.
Prime number.
Yeah, 2 is a prime number, so it's going to come to the bottom of our tree where our prime numbers live. Okay, and is 4 prime or composite?
Composite.
Very good. And 2 times 2 equals 4. Now, someone other than Jalen, not Jalen, I know she's got it. Someone other than Jalen, tell me, how do I know I've factored 40 correctly?
You can multiply all the numbers together.
Yeah, these prime numbers at the bottom, if I were to multiply all 4 of them together, it would equal 40. If it doesn't equal 40, yeah. If it doesn't equal 40, I've probably done something wrong, okay? So now I'm going to change my pen color. Now let's factor 24. Of course, because I know Tristan's in this class today and he's a high flyer. So if Tristan wants to go ahead of Miss Neville in the class, he definitely can. And go ahead and factor 24. Okay, so where's Miss Neville's mouse? There it is. So 8 times what number will equal 24?
3.
3. Notice what I'm going to do here, guys. I'm going to drag that 3 all the way down to the bottom. Emily, turn on your mic and tell us why.
I'm kind of new at this, so I'm trying to think of it.
It's a prime number. And remember, prime numbers live at the bottom. Tristan, can you cut on your mic and tell us what is a prime number? Is your mic working, Tristan? Cut it on for me and tell us what a prime number is. I can't hear you, buddy. Melena, can you help him out? Cut on your mic and tell us what is a prime number?
A prime number is a number that can be multiplied with anything else.
Right. Only one in itself. The only factors it has is 1 in itself and the number itself. So 3 is a prime number because it only has 2 factors, 1 and 3. Okay. 8 is a composite number. So 4 times 2 will equal 8. I'm going to drag my 2 down because that's a prime number. And then what 2 numbers multiply together to equal 4?
2 times 2.
2 times 2. Remember, I couldn't have put 1 and 4 here because 4 is composite. And only prime numbers live at the bottom of my factor tree. Let me say that again. Only prime numbers live at the bottom of my factor tree. Now, I know I've factored this correctly because I can multiply all 4 of these numbers together and they will equal 24. Okay? So my next question here, moving right on with our lesson, what's the GCF? In order for us to understand GCF, you may have learned this before, but we're going to do a refresher course. The GCF is the greatest common factor. And it means exactly what it says. It means exactly what it says. What's the largest factor that both 24 and 40 have in common? On this tree, what's the largest factor that they both have in common? Look at those two trees. What's the largest factor that they both have in common? Turn on your mic when you have the answer for us.
8.
8. Very good. 8 is the greatest common factor between 40 and 24. I'll give you a second to finish writing this, and Miss Neville will be going on in a moment. All right, so Miss Neville's moving on. As always, if Miss Neville's going too fast for you, you want to make sure that you watch this video to get any notes you may have missed or listen to anything Miss Neville has said that you need me to say again. So, finding the GCF. And can someone turn on their mic and tell me one more time, what does GCF stand for?
Greatest common factor.
Greatest common factor. Very good. So there's some steps we want to follow when we're finding the GCF. Step 1, we want to list the factors of both multiples. We want to list the factors of both multiples. So we've been doing that with using our factor trees. Today, Ms. Neville is going to show you a horizontal method of listing your factors that you've possibly used before. Today, we're going to do the number. We're going to use the number 50 and the number 35. Okay? I want you to watch how Ms. Neville factors these without using a factor tree. I always want to start off with listing 1 times that number. Those are the first 2 factors. Then I'm going to start going in order. After I've listed 1 times 50, now I want to put a number 2 there. Remember our divisibility rules. I know that 50 is divisible by 2 because it ends in an even number, 0. So 2 times what will equal 50? Think about quarters. 2 times what will equal 50? Someone turn on their mic and let us know.
25?
25, very good. 2 quarters equals 50 cents. Okay, this is not divisible by 3 because these numbers don't add up to divide by 3. This is not divisible by 4. Okay, is this divisible by 5? Yes or no? Is 50 divisible by 5?
Yes, ma'am.
Yes.
Yes.
Yes. 5 times what will equal 50?
10.
So the 50 are 1, 2, 5, 10, 25, and 50. Now, we want to list these factors of 35. We always start off with 1 and 35. Is this divisible by 2?
No,
How do you know that?
because it doesn't end in a even number.
Very good. Is this divisible by? Oh, okay. This is now, because it ends in a 5, it's also divisible by 5. And 5 times what equals 35?
7.
7. So the factors of 35 are 1, 5, 7, and 35. So now I see a list, 2 different lists of factors. What is the greatest common factor that both of these numbers have? Share.
5.
5. So the greatest common factor here is 5. The greatest common factor here is 5. Any questions here? And so if I had to do a step 2, it's really just one step in finding the greatest common factor. But if I had to list a step 2 in my notes, it would be identify the largest factor. That both numbers share. We're going to do one more example together, and then you're going to do some practice today on your own. Ms. Neville's about to erase this. Remember, this lesson is being recorded. If you need to go back and get some notes. And let's use a different color this time. Orange. Let's do 22 Let's do 22 and 33. Remember, we always start with 1 and the number. And then after I've done 1, I go to the next digit. Because this ends in an even number, I know something times 2 will multiply to equal it evenly. 2 times what will equal 22?
11.
11. So the factors of 22 are 1, 2, 11, and 22. with 33. Remember, we always start with 1 and the number, and then we work our way in. This is not going to be divisible by 2. Why?
Because it doesn't end in an even number.
Very good. So it is divisible by 3. 3 times what will equal 33?
11.
11. So the factors of 33, I put too much space between these numbers, but maybe you can not have as much space in yours. The factors of 33 are 1, 3, 11, and 33. So can someone please tell me what's the GCF here?
11.
11.
Very good. 11 is the greatest common factor that both of these multiples share. All right, so, sorry, y'all. So let's go ahead, and I want to share with you what you're going to be doing for the rest of the class period today, as I'm working with some smaller groups of students. Let me share my screen with you.